This tutorial is going to look at some of the basics of how Mantra micropolygon rendering works, and say a bit about sampling. We'll then go on to have a look at some of the basics of writing shaders in Houdini. Mantra micropolygon rendering is based on an algorithm developed almost 20 years ago, but still used today amongst other things because of the very efficient way that it handles motion blur and displacement. This algorithm is called REYES, R-E-Y-E-S, and stands for Renders Everything You Ever Saw. It's the same algorithm that's used in probably the most popular production renderer, Pixar's RenderMan, and indeed in all RenderMan compatible renderers. The walkthrough we're going to do here applies only to the micropolygon Mantra renderer, but in fact the ray tracing renderer, at least from the point of view of writing a shader, is very similar. So let's talk through the process that happens when Mantra renders an object. I'm going to illustrate this with a NURBS patch, but the method is the same for polygon, subdivision surfaces, and so on. I also need to highlight that the method I'm illustrating here doesn't describe how volumes are rendered, where the approach is slightly different. The first thing a REYES renderer, or Mantra, does is to convert the object to a format that it can split into smaller patches. For example, it's common in some renderers to convert subdivision surfaces into a Bezier surface and then render it. This step is invisible to the user. The next step is to split the object into more manageable chunks. How many chunks depends on how large the object is and how close it is to the camera. Very occasionally you'll run into problems because of the way these chunks are chosen, but mostly this too is invisible to the user. Then the chunks are diced into small four-sided polygons, called micropolygons. You can set how big these are, but by default they're sized so that when they're projected onto the camera, they're less than 1 pixel in size. This too means that an object nearer the camera will be diced into more micropolygons than one a long way from the camera. The next step is to run shaders on the micropolygon. For the purposes of this, we'll just look at two types of shader, the displacement shader and the surface shader, though you can also have atmosphere shaders. The first thing that's run is the displacement shader. It's executed once for each micropolygon and moves that micropolygon a little. Then the surface shader is run, which sets the color and opacity of the micropolygon. These shaders are run once per micropolygon. This may sound hugely time-consuming, but in fact is made quite efficient by using a computer technique called single instruction multiple data. So in fact the shader is running on a whole grid of micropolygons at once. But when you write a shader, you do it as if it were just looking at a single micropolygon. When the shader gets run, it gets a great deal of information about the micropolygon. Here's a diagram illustrating some of the common variables it can draw on. It also has access to any attributes you've defined on the object being rendered, for example a point color. Because micropolygons are generally much smaller than the objects or components of the objects that are being rendered, Mantra interpolates between the nearest points where values of the attribute are set to get a result for the micropolygon being shaded. Before we look at shading, let's look at sampling. Sampling is the control that's used to set a render's quality. In Mantra you have at least 3 different sampling controls. Let's have a look at the first, the pixel samples control. As we can see from this illustration, the camera fires a number of rays within each pixel, set by the pixel samples parameter. By default, these are at random positions within the pixel, because that randomness helps convert aliasing into noise, which tends to be less visible. Here we're looking at a micropolygon on the edge of an object, as seen through the camera. Some of the rays hit the micropolygon, some might hit the background. The color of the pixel is the average of the color of the samples. I've got a simple scene here set up with a box, and I've already set up a light and a camera. And if I set the pixel samples on the Mantra node to 1 and 1, and then render, we can see that the edges of our object have very poor quality. This effect is called aliasing. If I increase the pixel samples to their default of 3 by 3 and render again, we can see that the edges become a lot smoother. Pixel sampling is also used for reducing the amount of noise in motion blur and depth of field effects. But it's important to understand that pixel sampling doesn't control the number of times the shader is run. The shader is always run just once per micropolygon, and as we saw earlier, the number of samples does not affect the number of micropolygons. The samples are just the camera shooting rays at the micropolygons in order to sample the geometry. In fact, it's possible to visualize micropolygons, and we can do that using a special shader. And I've written one here. Let's dive inside and see it. It's very simple. All we have is a non-deterministic random node attached to our output color. And what non-deterministic random does is generate a new random number every time the shader is called. And as you can see, this random number doesn't depend on the position or the S&T coordinates. You simply get a new random number every time the shader is called. Since the shader is called once per micropolygon, each micropolygon will have a different color. The other thing that we need to do is make some changes to our object. And I need to add a parameter to help me visualize the micropolygons. And this is available here, and it's smooth grid colors. So if I right click that and install it and accept, we should find that we have a smooth grid colors option. The other thing that I need to do is change our dicing parameters. As you can see, we have a parameter here called shading quality, which is set to a value of 1. Shading quality controls the number of micropolygons that are in a pixel. In other words, the size of the micropolygons. And this is the second sampling control that I was mentioning. If we were to put this up to 2, for example, then there would be 2 micropolygons in each pixel. So the shader would be run twice for each pixel, and that would increase the quality of your shading. It's usually much better to address the issue of shading quality within the shader itself by providing, for example, sampling parameters in there. But you can increase the number of times the shader is run by increasing the shading quality. Equally, you can decrease it, and I can give it a value of 0.1. And this means that a micropolygon will be 10 times the size of a pixel. And this is going to make it much easier to visualize our micropolygons. So let's render. And I'm using the mantra renderer here, using mplay, because if I used the IPR viewer, we would be ray tracing the scene, we wouldn't get the same results. And as we can see, we've got a lot of random colors, and in fact we can see the objects, these NURBS patches, have been split into elements, and then they're subdivided into micropolygons. It's actually easier to see the micropolygons if we turn off our smooth grid colors. So let's do that and render again. And now we can see much more clearly our micropolygons. Each of these is a single micropolygon. The final type of sampling control is ray variance and aliasing. And this is also found on the sampling tab of the mantra node. and it's these two parameters here, min ray samples and max ray samples, and ray variance and aliasing is usually automatically enabled. And this only applies to micropolygon shading modes. It doesn't apply to ray trace mantra renderers. So the purpose of this is to determine how many rays mantra will shoot out into the environment to calculate things like reflections and refractions. And it has a maximum and a minimum. So the minimum number of rays shot out into the environment is 1, and in this case the maximum number is 9. The amount of rays sent out depends on what those rays hit. If they hit a very simple background, for example a solid blue environment sphere, then there would be no need to anti-alias the result, and so only a single ray would be sent per micropolygon. If, however, we were looking at a very complicated background where each ray was returning a different color, then mantra would send out something nearer the maximum ray samples. So that's a brief introduction to how mantra renders and sampling in Houdini.